Have you ever experienced the anger or the frustration of being in an online game and then you go to a match and then your match is so unfair that you are, for example, level 2 and you go against people level 60, level 100, and then you want to quit that game because that's so unfun to play, so unfair. So that's the problem we want to solve. A matchmaking algorithm to make the games more balanced. But in order to that, we have to develop a matchmaking algorithm and evaluation match algorithm.
So to put it simply, the matchmaking algorithm is the primarily based on the whole code is what signifies that all the players that are created are in a similar level, depending on another level that is given. Then the match evaluation algorithm it makes sure that all the players that are in that group or in that match are similar to each other, meaning you can't have players going from level 20 to level 80. All players must be, for example, 20 to 25 or 24 or 20 and 18. There are similarities between them. And the majority that, or in her case, the one person or people that this problem goes to or addresses ends up being developers, video game developers. Why? Because most games suffer from the problem that most matches or online games are unfair and unbalanced. It's not fun to play at all. It's unfun to just get destroyed playing online games. So the primary objective of this whole software that we created was to try to find an algorithm that can create those perfectly balanced matches with as little error as possible.
The main features of our program are divided in, for example, a player class that stores or gets all the classes, the player attributes, and all the methods to get that attributes. The data class that it makes all the data or gets all the data of the players to now match them, and then you can use it for matching algorithm. The data generator, in our case, we use a generator database. We didn't use an existing one. We did generate a database according to the parameters we asked. For example, to generate 20 players, 100 players, 1,000 players. It depends on which amount of players you want to generate. And also uh, a team option that you can choose to have a match in teams or a single player. Each one you choose, the match is going to be balanced, and there's going to be the problem of being like level 80 versus level 1.
As well, we created a user interface system in which all that it does is it will ask you for the total amount of players that you want that match to have, as well as a level that we can use sort of like a base or medium to calculate what would be like the other random generated players' level, so it's balanced. We also created an error handling problem, which in our case, in our software, what it does, it'll take, for example, if you have 10 players, you can't decide to make teams of four because then it's not really divisible 10 by 4. It gets a rational number. So we have that error system, so it always has the same amount of players per team, so it's again a more fair match. We also have the randomizer, which in our case we use something called the MT 19937, I believe it was called, which MT is itself the device, which stands for, I believe it was mirror and twister. Then the number itself is the seed that you input in that device. What it will do is every single second the program runs, it'll grab the seconds, turn it into an integer number, then by that it will create the actual numbers based on the parameters you set it. Meaning that every single time you run it, or every second that it's running, it will create new randomized numbers every single time, therefore reducing the the percentage of the numbers being repeated. As well as for our justification of why we use what we use, in our case, we decided to use vectors. We decided it was the most simple way to use it because it allows for easy access to sorting, to finding, to searching, and as well to manipulating all the data inside of the vectors. As because in linked list we couldn't use it because then we also have to use more memory to create all the pointers or the references to the next value, and as well with the linked list we have to go value to value and able to fully use it correctly. With stats, it's just too much of a hassle, deleting all of the top of them, then find the one we want, then repeating this again. As well, since vectors use dynamic memory, you can input at any size you want the vector, really won't matter. You can add more parameters, for example, the region of the place or other characteristics, and the efficiency of the code won't matter at all. So our code particularly bases off on it creates one vector, creating of all the player parameters, the ID, the name, and the level. Then should you choose the option to actually do teams, then it will create another vector using those player vectors in order to sort them out. By first, it will sort all the vectors in all the vectors, sort them out, then put them in all the vectors, then divide them into groups.
Okay, our BIGO analysis, according to the BIGO, we analyze the efficiency of our code. We analyze principle the sorting algorithm, and the code employs the std sort that is a standard library in C++, and this has operation time complexity of total players times the logarithm of the total players. This is an efficient code in the in the medium way, not that efficient, but that doesn't take that a lot of resources or time. It's very efficient to meet data sets, and the overall efficiency, the code efficiency is generally good for small to moderate sized data sets. However, for very large data sets, the sorting step could be a limiting factor. And also we analyze the data, the group, the group assignation and the data creation, and that's a pretty efficient algorithm. It's independent on of the total players, so that's very efficient. So our code is efficient in the medium level.
And as well, this will be a flowchart. It's rather simple. In our case, we first ask for the data. Well, the data is registered. Then it will look or create a match. While it's looking for the match, it will also, if there's not a match already existing, it will create it. Then while creating it, it will access the database, get all the information, then assign the players to that match, depending on the data you already input. And as well, it will check if we have a full match or not. If we do have a full match, it will look for another match. If there's not, it will create one, repeat this process until there's an empty match, and then it will assign that player to the match.
In this part, is going to occur a sub process of comparing players, and it's going to place on are they of similar level? If they are not, it's going to repeat. It's going to be a loop, and if they're similar levels, then you'll put the players on a match. After that, it's going to ask if it's going to be a team match or a single player. If no, it's going to be a single player, and then end the program. And if you want to assign in teams, then it's going to assign the players in teams, divided in teams, and also it's going to end the program.
And then we'll put the actual code. When it charges. Right. No, it's working. Okay. There you go. There you go. Okay. So we can add any amount of players. Let's say we add 15 players. After those 15 players, then we'll decide if we want teams or not. Should we want teams? Please add one. And then we get into the team size. And here we say that it has to be a positive divisor of the total players, so it's balanced. So let's say 3 teams of 5. And then we can add any level like 67. And then over here it will create, well, we got bad luck this time. It will create 7 teams around about the level we gave was 77. It will create 5 lower and 5 above, which in the majority of the games it creates a pretty good balanced character. Now we can rerun this. And let's say we want 10 players and we don't want teams. We just ask for a level, and we'll just give them all at once, and that's practically it of our project.